And this will be a great place to kick off on the recording. So there are a lot of efforts going on, a lot of ontology efforts in the world. There's Protege, UFO, these are top level efforts, they're mid-level efforts, they're domain efforts. Of course, BFO here in various extensions. For a long time, it has been sort of the UB in core position that we just, and by we, I mean Barry, just kind of beats everybody else into submission. With a privileged interpretation of how the world is, there is there's a lot of value in such an idea, I think. So I'm not casting stones. There's a lot of value in getting people on the same page. Um, no doubt, and Barry has demonstrated that regularly, routinely, by getting people to use, common sense. He would say commonsensical framework for understanding the world, and it has paid off in with significant dividends, I think, over the years. That said, um, I think we're at a place where we can, as a community, especially us over here in the BFO circles, given how much BFO is used, how widely it's used, how it's been, I think we're in a position where we can sort of um, accommodate other perspectives, accommodate other kinds of representations. There's so much BFO content, so much more orders of magnitude than other ontology efforts. I think it would be wise to be able to just, in a sense, represent those other representations, at least provide a place for them within the broader ecosystem, and then connect the efforts like UFO, Dolce, up with what we do, all the ecosystem that BFO has. And so to make this halcyon dream achievable, it's not what the way we shouldn't approach is going to say Giancarlo and saying, hey man, hey you know, why don't we figure out what classes in UFO are like the classes in BFO and then work our way down the chain. I think that's not the way to go. I think he's a lovely man. I think he'd be amenable. He'd be like, let's do it, man. He's a lovely man. I don't think that's a wise choice because ultimately, at the end of the day, to my mind, what we need, I think, is not like representations like static files like BFO and UFO sitting on some repos somewhere, and then maybe a static file sitting between them that is somehow an aggregation of the two. We need something that is also an ontology, I should say, and has like ontological principles governing its development and use. What we need something more executable. We need something that you feed in to an application to do translations or connect these structures where they need to be connected when they need to be connected. And that is not, to my mind, an ontology so much. Sometimes I'll refer to it as like a mapping ontology, but I don't actually mean it in the same sense of like an ontology insofar as I'm not really concerned with aligning to top level structures. I'm not really concerned. I'm concerned with being guided by them. But at the end of the day, to me, it's about formal logic. It's about logical translations across the semantics, which may or may not look very similar to what you see in the upper level ontologies, especially given their limitations being represented in a language like OWL. Ultimately, what I'm looking for is logic that I can use to write code so that I can construct mappings or when I need them in applications across these different structures. So this is the sort of thing that I did at APL. It's the sort of thing that you can see manifest somewhat of in translation definitions in the great work that Tim and Giacomo and others in Austin as well did in that provenance and BFO mapping paper. Some of the work that you see going on with Alex Scully working on SSN or and some of the preliminary work, or like at least preliminary stabs of this sort of work with the GIST BFO mapping effort going on, as well as the BFO IES mapping effort that's going on that is very much a part of. So what I'm saying here, there are lots of mapping. I am trying our best to shift into a space where we're building a lot of mappings that are formally rigorous, mappings on which we can write code, mappings that may or may not look like ontologies, but certainly are rigorously defined the way ontologies often are. So that is my background. I think Tim has his hand up though. Yes, sir.
Yes. So I read some of Michael Gruninger's work about mapping different, well, was it map? Yeah, I guess you could, I don't think he called it mapping, but relating different theories, like formal theories. And he had, I think one of his ideas was that when you're able to connect these theories together, they kind of help in a way justify each other or they add more justification. And I think could probably, intuitively, it's like if BFO and UFO have the same concept, some sort of equivalent concept, I think that really gives just extra justification for the concept, right? So it's I don't know, it's just an idea that I remember reading in Gruninger and I think that's worth like uh yeah, highlighting. It's like, wow, these two different systems have sort of the same idea, they're just represented differently. And if you can connect them, then like, they're probably right.
Mm-hmm.
There's like this, I guess in the when they were trying to come up with a definition of computability, I think this happened where there were like several different definitions and they ended up being this like equivalent. And it's like, oh yeah, this is probably the right way to think about it because we've all arrived at this idea independently. So anyway,
Absolutely. Like a
yeah,
bunch of independent researchers arrive at the same conclusions. Probably a good conclusion.
yeah, yeah.
No, that's a great example too. So I'm not surprised because so the work in the Provo BFO stuff, I spent a lot years studying Michael's work in
Mhm.
translations and mappings. Now, he had students who were working on creating formal mappings between like Dolce and the lattice structures in the Calore repository. And when I was a graduate student here, I did the same. So I was constructing mappings into the lattice structure on Calore. And I've often thought Calore is like the data, like that's where the data is for all the structures that we need. And so it's kind of like a lingua franca for mapping all the ontologies. Ultimately, at some point, Calore is going to make its way into these projects at like that kind of the data heart. I'm not sure if it's going to be as a training data or just something to check ourselves. That's TBD, but I'm not surprised. I'm very much influenced in my thinking here by Michael's work. And that BFO Providence stuff. I mean, I hopefully I said this, but um, when we were talking about it, but like to my mind, this was kind of making real what he'd been doing, like implementing what he'd been doing for years. Because otherwise, he just had students creating axiom translation definitions. And I was always like, how do I use this? How do I use this? Give me something I can read or my machines can read. So yeah, not surprised, but you're right. Okay, so you're right to point out it's a great observation about like the kind of mutual support. Some of the other kind of consequences we might point to of like doing these sorts of mappings is not just the way they might mutually support one another, but the way they might mutually improve one another. And so I could see this in the GIST BFO effort. So the GIST team recognize that these concepts that they've been discussing in house for a while, for like months. Um, Once they looked at BFO and saw how BFO handled the same area, they were like, "Oh, well, that's easier." They told us on the call, they were like, "You actually clarified, like looking at this clarified a lot of things, and we're actually going to get rid of this class that we've been playing with, and kind of have a structure more similar to your GDC difference," which was very useful. One of the reasons, incidentally, that I chose the three mapping um, topics for project three was in this vein. So the BFO IES, that's because I believe BFO can illuminate some of IES. The other directions, QUDT and CCO, as well as gosh, what is it? The time ontology, W3C time ontology, and CCO's time model. I think those QDT and the time ontology can help improve CCO. And so I want, and it absolutely needs to be matured. And so The BFO-IAS mapping, which I'm going to talk about each of these in a little more detail. I'll let you, in fact, maybe I'll just start here. BFO-IAS, this is the basic form ontology, and there's a mapping effort going on between it and the Information Exchange Standard, which is being used in the UK and I believe Australia, to model intelligence, the intelligence domain. So this is part of a Five Eyes ontology effort. We meet every other week, many of us at 7 a.m. because we want to make sure that our OSCE partners aren't asleep. We work, we talk, we argue through mapping between BFO and IES. We have two teams now, one focused on kind of the high level theory, what you might think of as like the human understanding semantics around the representations. And then we have an implementation team. We're actually going to do on the ground work. This effort has gotten to a place where we just published a paper in JOO about what we've done, where we constructed a bunch of I say we, but like and Giacomo, Elena, Andres Cola, and Helene, I think is it Helena? Helena, and I'm sure other people, but you five were the ones that, yeah, in Partridge, they kind of put together and worked through the development of design patterns and use cases between BFO and IES. So if you're interested in seeing where that work stands, that paper is already out. But yeah, there'll be more of the design pattern stuff, but also a lot more going forward of the actual implementation work, the implementation work that you will be seeing in Project 3. So we will be contributing in our efforts to that ongoing project. And my hope is that if you're interested in both completing the Project 3 and continuing on and providing some support for that mapping effort that's going on, you too may join our papers, and you too may join our team, even if you're not willing to get up at 7 a.m. Because there's going to be plenty of mapping work to do, and I actually implementing mapping work to do. On the other hand, the QUDT and CCO and the W3C time and CCO, as I said, I think these mapping efforts they are also part of a larger effort going on under the IEEE. I am one of the leads on this IEEE effort to standardize CCO as a mid-level ontology. But CCO, has varying degrees of maturity in its modules. And a paper published in Voice last year kind of outlines what I take to be the game plan forward for maturation. And there you'll see I reference specifically aligning QUDT or learning from QUDT and the W3C time ontology. So this has been this is not like new. Project 3 is born out of a plan to again help mature the IEEE or help mature CCO into the IEEE. Here I'm thinking that CCO's time ontology and CCO's units of measurement ontology would very much benefit from really just being thrown away and improved by adopting QDT and the time ontology. But, that is TBD. I don't want to just throw out everything. There's some good stuff. The name of the game here will be to identify mappings to see where the relationships are and see where there are gaps and see what CCO can learn from these other efforts that have been around for a while. And if at the end of the day it ends up being the case that, look, we should just use QUDT, then there'll be a QUDT CCO version, and I'd be okay with that. But we'll have to prove that to ourselves and prove that to the IEEE community as well. Which incidentally, they're sympathetic already. I've been priming them for this. Okay, so that's high level, why would we map? What are the projects that we're going to be working on? How do they connect up with some bigger efforts? Just about everything I do and everything I'll have you do does connect up with some bigger efforts. So, there's always going to be other people working on this too, inside and outside the class. And I guess before I stop talking, I do want to say, because I mentioned my halcyon dream, this metaphor, this real anecdote that to me I find very powerful, but I think puts kind of a bow on everything I'm saying with respect to mappings. And it's something that I hope you will repeat. And I hope everybody will just kind of buy into. So train as a mathematician, one of the first things they teach us is if you get stuck on a really hard problem, translate it into another language, formal language, and see if you notice anything different. To me, that's what I want to do with ontological representations. But doing that translation formally, doing studying math is hard. It's just really hard work. And sometimes you have to create a language. Sometimes you have to do all this. And it's like, I want to automate as much of that as possible. I want to leverage machines to do the translation. We have these static structures already. I want to be able to push a button and translate between UFO and BFO representations, or Dolce and BFO representations, and see what changes. That will help me, I think, help us identify new areas of research, gaps in our representations, be able to understand data in a different way with a different interpretation. And that to me is like the scientific endeavor, man. There are lots of hard problems we don't know how to solve yet. I want to be immortal. Not even sure how to research that. Hopefully, with enough of this mapping stuff, some genius will look at what we've done and be like, ah, you know what? I'm gonna focus on this. But we got to help them so they can help me. I mean, help them so they can help us. Okay, I'll pause. Questions, comments, concern. Compliments.
Absolutely.
Sam also wants to be immortal. I love it. Finally, usually people are like, you want to live forever? I hate my life.
Yeah, I think that sounds pretty miserable, to be honest. You got to watch everyone you love die.
If that's the cost,
Fair enough. I mean, to each their own, I guess, right?
I would, if Horcruxes were real, you'd all be in danger.
Well, speaking of, they're doing a bunch of like quantum biology stuff lately that might lead to that. I don't know anything about it, but it seems interesting.
So we are week 5. Hmm.
John's saying he wants to be immortal now because he thinks about all these good things that are going to happen. And then, but immortality is going to be him doing this lecture over and over and over again.
No, man, no. Obi wants me to repeat the mapping idea for the immortal. Was this a joke? Because Mike just said I was going to repeat this forever. That's amazing. I want to be able to map these different representations together. And if you're having a hard time grasping what I'm talking about at like kind of the top level UFO Dolce, just think about it at the domain level. Like you have different representations, or like aerospace, right? You have different standards, groups. You have different standards. Like this group over here might represent the same domain in a different syntax and semantics. Like this is the whole interoperability challenge, right? But look, like they're representing that group is representing that domain the way they are for a reason. They might not have your reasons, but their reasons sometimes might be valuable to you without you knowing it. And why like straitjacket yourself into a single perspective and make it harder for you to understand reasons that might be important to you in a broader context, just because of the way your syntax is, just because of the way your computing environment's set up. So I want to be able to map between those, explore these alternative perspectives, alternative ways in which you might view the world, even in the same domain, partly or all the way down to the domain level. Because I want that bigger picture. Who knows what the world's going to throw at us? It could be like, hey, John, be immortal. I want to do that. Or it could be, I need more evidence to know this isn't a hospital if I'm going to bomb it. And maybe the perspective I'm taking right now makes it challenging to see good reasons not to bomb it otherwise. And I don't want to have to wait for an intel analyst to think really hard and hopefully call me before the bombs drop. That makes sense? I do like Austin's claim that one must imagine immortal John happy. Indeed, sir. Indeed. One must. The only thing that makes sense.
John, practical question about Project 3.
Mhm.
Because now is the time to shoot that now.
Yes, sir.
Um, Scoping wise, you sort of created this program that sort of analyzes the structure of ontologies, the entries of ontologies, and then tries to map it based on those structures.
Mhm.
Um, I looked it through and I actually sort of commented it with ChatGPT and it sort of worked out. I mean, it sort of said you could even explain what it was doing. I was pretty much amazed.
It's great. It's awesome.
Yeah, but scoping question. I mean, are we more or less supposed to stick to that program, or are we supposed to improve the program? adjust the program to replace the program, because there's these three ontologies are all different, and my gut feeling says they need different strategies. But yeah, and I've been thinking about it a bit, but they they really are different
They are.
in characteristics. So I'm sort of like, hey, once you go, you have to go all three, and that's just tremendous amount of work.
That's right. Here's the thing. So this project, as you walk through the steps, you're going to like the code is written specifically to make very clear what you just said. There's going to be a
Okay.
halfway point when you're looking at the output and you're going to be like, shit, that's not what I expected to see.
Mhm.
And then you're going to look at the little help guide down at the bottom and you're going to be like, okay. And you're going to be interpreting and you're going to run it again. And you'll be like, okay, what game is John playing here? And then you're going to keep walking through the steps. And then you're going to see that I had you kind of not embellish the code, but sort of embellish the structures and then run it back again. So you're not just going to run it once, you're going to run it a couple times. And then you're going to start, you're going to have the opportunity to kind of have these representations meet a little closer than they would have otherwise. But you're not going to be able to get there through through the owl, you'll see. You have to get there by interpreting the textual definitions and the comments and the descriptions.
Got it. So the mapping program is not leading in this.
It is essentially there to highlight what is
Yeah,
missing, both on
got
a
it.
technical, like formal
Yeah,
representation side, as
yeah,
well
got it.
as how challenging it is, like what exactly I'm asking for is when it comes to mapping. So mapping is not trivial. It is not a trivial thing to do. um, and that will become clear.
Yeah,
Yeah.
yeah. So more practically, one of the ontologies or combinations just failed to map from my perspective. Uh,
That's
my conclusion was giving the scoping. Well, that's that that's that not my problem, but it
right.
remains my problem. I understand.
It's evidence though. It's evidence, right?
Yeah,
Yeah, like check this out. You ingest an ontology that has no axioms, basically, just subclass
yeah,
hierarchy. And you ingest an ontology that has like rigorous axiomization. And then you say, where's the structural similarities? Your answer should be, if anything, it's just subclassing. And if you wrote the code like if you have a script like the one you're playing with,
yeah.
just kind of ignores the subclassing, like straight subclassing, you should get nothing. You should get no results because what is the structural similarities?
Yeah.
Now that's a problem. Not for you. I mean, well, it's a problem with the ontology.
Yeah.
Because what is
No,
it
but it,
like? Think
yeah,
about somebody asserts a class and they say, like, let's say this is not the case in BFO, but let's say somebody asserts material entity is a subclass of independent continuant. And they just assert, they give a textual definition, but then they just assert this ALSA or RDF as subclassing relationship between these two classes. What does that mean? Ignore the label. What does that mean? Think about it like a computer. You've got constant, subclass of, constant. So you have a reserved vocabulary term. You know how to interpret subclass of, but you have no idea how to interpret these black boxes that are flanking it. How do you interpret how do you like add content so the machine can interpret those black boxes? You add axioms, you add logic around them. That's what the machine eats.
got it, got it, got it. Okay, but not really like going to the length of just reading the whole ontology and saying like, okay, I think I can map 60 to these five BFOs by hand. I mean, that's not what is. I mean,
No, 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 no.
given immortality and all the
Yeah, give it
time, I mean, we're
immortality.
discussing that aspect.
Yeah. That's right.
Okay, great.
So at
Yeah,
some point, okay, so at some point, I'll just kind of like so that you don't get too frustrated. Anybody, not that you're getting frustrated, but so that you're not too frustrated. Look, so we're gonna be poking through the textual definitions as a way to construct axioms to align these representations better, and then we'll have structural similarity checks to see when we've done our job well, and then we'll be able to like sanity check ourselves to see like if we as we've added axioms that they are matching up the way we intend. I don't want you though to spend your life constructing owl axioms for these different representations, but that's okay because after we get through our pipeline that will kind of eat some of this code and kind of create a workflow that we can check and use and automate a lot of this, we're going to introduce machine learning aspects to this. Machine learning, we can ingest some of those textual definitions and construct axioms out of them. We start adding, right? And then when that fails us, we'll use some of the more sophisticated NLP, right? We'll use some LLMs to help support different aspects of the workflow. So at the end of the day, we can not just evaluate ontologies as the output of our tooling or our pipeline, but we can also start like semi-automating, or at least automating a considerable portion, I think, of the mapping workflow.
Got it. Got it.
You
You
got
could do a nice statistical. You could actually do sort of a nice statistical thing there, sort of sampling with an LLM from a well-mapped ontology, and then sort of having two ontologies that are not that well mapped. But
Mm-hmm.
if you have a sense of a distribution of what well mapped looks,
Yeah.
you could say, given the fact that we know with an LLM what well mapped looks,
Mm-hmm.
this is likely not well mapped.
That's right. And I
That
think
could be sort of a statistical angle.
that's right. I think we can leverage some of that Calore repository, which has a bunch of well-mapped, not ontologies, but lattice structures and a theory of hierarchies that governs how they relate to one another. So like linear partial orderings related to like Dolce's like exists at module in this way, and you can like construct a formal mapping between them based on simple logic. That's what can be eaten too, right? And that can be in training or it can be used as a check, right?
Yeah.
We're gonna do some cool shit, guys. So again, you should see some surprises. You should. Part of this exercise, though, just again, want to highlight. Part of this exercise is getting you familiar with using things like Notebook, getting you familiar with looking at the syntax of like paths, uh, getting you familiar with like leveraging like RDF lib, generating Sparkle, using Sparkle wrapper within it, right? So I wanted you at some point to study the code and be like, and then adjust it slightly so you can pull back other things in the Sparkle, like because there's embedded Sparkle queries. So I wanted you to get comfortable playing with that. So I did set up a lot of it for you, but it's because I want you to get comfortable writing some of this yourself. And you should know how to play with people. Does that make sense? Okay, so I definitely want you to kind of walk through those tasks. And if something doesn't work, if you see like some block, some check fails, you might have to go do some spelunking. So, for example, it's Christian here. Christian submitted. This was for project 2. This is of the same sort. Christian put a pull request out, and he was like, it failed the checks when he pushed it over to me. And so I went and he's like, I don't know what's going on. I haven't figured it out. And so I went and looked and I just checked the workflow and I saw where the error was. And he had, for whatever reason, duplicated in the path ontology hyphen trade graph. And so because of that syntax difference from where the source files were and where the path said they were, he was failing the check to find BFO turtle files. Now he's got to go figure out why there was a duplicate in the path. Debug. And unfortunately, you can leverage LLMs to help you here for sure. They'll definitely save you a lot of time, but unfortunately, you just gotta have to learn how to debug shit. That's just the way it is, man. You just have to. It's a good skill to have to. And even more fortunately, you guys are in a better situation now than like, I don't know, people older than you because you don't have to go fight with people on Stack Overflow. Nice. Yeah. Those people are jerks. They'll hate you to death. You don't have to ask questions over there. You can just ask it to a nice chat bot that's through reinforcement learning, trained to be your friend.
Is there any ontology action on Stack Overflow?
There's a little, yeah, actually. There's some more semantic web action. So if you check
Got
out
it.
look up semantic web, you'll see more of that. There's more recently a lot more knowledge graphs.
Yeah.
They usually are asking implementation style questions, although you will see on occasion some people, read a paper of Barry's and say, "Let's start a conversation about realism." And everybody's like, "This ain't the place." So you see, you actually learn quite a bit, I think. You can learn quite a bit from studying some of the questions on Stack Overflow and the kind of broader space of because in other communities they ask questions around this space. If you're like searching for RDF, RDFS, SCOS, Dublin Core, you'll find some interesting questions or Sparkle. Yeah.
Oh, by the way, one note about the realism thing and consensus and being able to communicate how you think reality sort of can be described. I mean, those two things seem to be the same, no? I mean, if you can get to a no, and anyway, they're related in a sense. If you can get to a consensus, then seemingly that corroborates the fact that there's a shared reality, which sort of corroborates, yeah,
I
realism.
think so. It's like evidence, right?
Yeah.
I think that's how Tim intended it. And that's certainly how I would intend it. Like this corroborating evidence. Like, oh, and you can see an extreme case of this described by a philosopher named Hilary Putnam, who was talking about kind of the formalisms of mathematics and how whether or not we should be realists about it, like whether we're actually lining up in the real world. And he gave kind of offhand this what's been known as the miracle argument, where he's like, it'd be a miracle if our mathematics were so precise, like down to these decimal points, like independently corroborated by all these other research. It'd be a miracle if the world were different, right? And there's some truth, right? Like it's certainly evidence. He's making a broader metaphysical point about now you should believe that there's a real world out there. That's a different question, but we don't need to go that far. We're not doing philosophy. We need to go far enough, and as far as we need to go, that corroborating evidence is useful. So Tim, this is interesting. So I got this. There's this project I'm part of with some folks on trying to figure out the best level of expressivity to ingest the documentation at. So like different serializations of RDF are different, have different expressivity. Like XML is more expressive than Turtle, and there's at least there's some interesting results. Not always, not the most expressive is not always the best to help like minimize hallucinations. But then the hallucinations come in different types, and so some maybe the Turtle is better at handle some rather than others. We don't know why. It's kind of an interesting, outstanding research question. But you're right. Like using that as kind of a source base to check is that certainly can help eliminate some of the bias.
Something I want to mention just because I've only started using LLMs in my for programming like in the past 2 months. And so something I've noticed is generally you it's helpful for me to create new context, new conversations as often as possible because the way that they work is every single uh word or sentence that they're predicting, they're using the entire context, the entire conversational context. So what can happen is if you're talking to one in a conversation for a long time, it can start to get confused because it's trying to, with everything that it says, trying to take into account like the entire conversation history. So whenever possible, I try to make a new context. But at the same time, when you do that, you want to like refresh its memory with the context that it needs. So um, I'm just mentioning that because
Yeah.
I think it's helpful if you're using these a lot. Yeah.
I've like sometimes when I have free time, like when I'm stuck on planes or something, I'll create these long story, like consistent stories. And I keep asking questions, but I'm always like threading around the same lines, like the same basic four principles and just elaborating on them in different ways. And I found that if I do that for long enough, I mean, I can do that for a long time and it sticks with the story. But then the longer I go, if I throw in one slight slight deviation, all hell breaks loose, right? Like if
Oh,
I do that early on, it'll like, okay, whatever, either accommodate it or explain it away. But if I do it later, it just starts telling me a different story. All of a sudden, it's kind of interesting. It like forgets what I was previously talking about. It's like, okay, instead of accommodating, I'm gonna sing you a story about walls now.
yeah. Also, practically speaking, if you're using one that you're paying for, the longer the conversation, I think you will use more of your quota because it's just gonna, it requires more processing
Mhm.
the longer you're talking, right? It's just gonna use the entire
Yeah,
history for every prediction. So, yeah.
I'll do that. We're poor.
Another helpful little LLM tip, the more information you give, the less effective it is. Like studies show at least that it does better with the less amount of information it's given, but obviously you want to give it all of the context of whatever you need. So it's like a battle between all of the information and as little words as humanly possible. So that's something to consider as well.
This is something that came out of that research on like which serialization of RDF to use. Like, because we're like observing some of this balancing act going on. Like, we have a battery of questions or benchmarks that we're checking. Can you answer these inference questions? And then like, the suspicion is like the more expressive. So there's some middle ground between like turtle and like the most expressive serializations at which it's like optimal for answering the questions. But like it kind of is bad using the turtle, and it's kind of just bad using the most expressive one. Or like I'm saying most expressive. I have in mind RDF XML, because that was kind of the boundary case we were looking at. But it's fascinating.
Yeah.
Okay, so let's see. So I will pause for a second. If you have any more questions about Project 3, say them now. I do want you to work through it, I kind of left a lot of breadcrumbs. I wanted to make it clear, what you're doing at every step of the way. It shouldn't be challenging technically to just pass the test. If you do that, like, it's fine. You won't get as much out of it, obviously. But you could basically just create a bunch of files, like Excel files, and like put nothing in there and check it. Or actually, you couldn't get by with just doing that. You'd have to be a little cleverer. But I assume some people would try to do that. So it's like not today, sadly. Um, but walking through the process, though, the workflow, you will learn a lot, I believe, and it will be valuable for you going forward. So do that.
I guess I have one quick question. I submitted it already, but so I'm pretty far behind, I think, from most people in this class on like technical stuff.
Mhm.
So I spend a lot of time debugging and working with ChatGPT and whatever, figuring out how to write the code or fix the code, whatever it might be.
That's good.
In doing so, I have to like review what I've submitted afterwards to learn exactly what I'm doing. So my question is, what would you say are like the main things I should focus on over the next couple of days of learning what I've submitted to ensure that I know it by the end of the week or whatever?
Yeah. Yeah. Understanding, I want you to leave with like a hands-on, practical understanding of how to use Jupyter Notebook. Like why, like what's valuable about using it, like why you would. I want you to understand how to like embed with into using Sparkle queries, and like construct, change them, adjust them as you have them, and call them using with RDF-lib. So I want you to be able to do that. So studying that, those are crucial. Also, getting an understanding on what I mean, and this you'll bear this out by looking at the help guide for that compare structures Python script, as well as just thinking about what the script is doing, or like running it through GPT and asking it what it's doing. I want you to get a real deep understanding of what exactly it means to be structurally similar or semantically similar across ontologies. And it is, in a nutshell, just intuitively, what I was just describing, that is kind of the key point I was describing there. I said, if I just said this class is a subclass of that class, as far as the machine is concerned, It knows what subclass of means because that's part of a reserved vocabulary it's defined. It knows how to interpret that, but it doesn't understand what the flanking black boxes are. The way you provide it information, a machine information, so that it has a better understanding of what the semantics are, what the meaning is, you have to add axioms that characterize it, explicit axioms that characterize what each of these things are. So when I say material entity is a subclass of independent continuum, I want to add semantics to the material entity class. I have to say things. I have to literally assert things, not just in text, but in a formal language like OWL, has part material thing. Or I have to say, because material things have matter as parts. Something like that. I have to add more content to it because it doesn't follow just saying the material entity is a subclass of independent continuate. The material entity has any parts. I have to say that. Does that make sense?
Yeah, perfectly. Thank you.
It's that basic logic. And then you do that across structures. So when you get to IES, you're looking at that structure. You see kind of the lack of axiomatization, as you will. Observe. This happens all the time. Some groups don't put axioms in. And so effectively, if you're looking at it from a machine perspective, machine doesn't know easily read what's going on, right? Like text is ambiguous, OWL is not, right? And so there are many ways that these classes in IES can be interpreted. We are learning this. I will point to you an example from just looking at their textual definitions. We were writing up descriptions in the preliminary section of this paper for BFO and IES, talking about the design patterns. I was walking through the IES section with their definitions. I was reading their definitions and I was like, uh-oh, I don't know how to understand this. I went to their OWL file. They didn't have any axioms. And what I left on their comments were, there are a bunch of use mention confusions going on. This space-time thing doesn't link up to that. That doesn't make any sense. I was just drawing connections across their textual definition. I'm sure they were just ambiguous and I was misreading them. But I don't know because I went to check the OWL file and I got nothing. So what hope does the machine have? I know the domain. I know what they're doing, and I still couldn't figure it out. So we want to get them to a place where it's unambiguous, where the semantics are unambiguous. And here's one way to help identifying what it means to be disambiguated, the level of the formal language, and then how do we connect that up to existing unambiguous structures so we can highlight gaps, differences, similarities, and both be better off for it.
Yeah, from one perspective, John, what you're sort of saying is like currently LLMs are trained on natural language, and you can then try to use that model to rub something into an ontology. But in a way, you would like to turn it around and say, no, listen, the ontology is the structure. That is actually, that determines, sort of, that's a real structure with some deeper thought and meaningful structure.
Mm-hmm.
And if you could track that structure, sort of, yeah, you would. I mean, I don't think it's readily possible, but in a way, it's sort of like, hey, these axiomatizations actually give that structure which is meaningful, which it would like to recognize, which is what LLMs do in a way.
Yeah.
Yeah.
Yeah, that's good. So I like this way of pitching it because to me it is something like a turning and it's on its head. And I gave a talk like last week where I was advocating for like a different use of LLMs than what you commonly see, which is more in like the forefront brute force. Let's tweak, let's use RAG, let's like tweak these things, let's use ontologies to check them. And I was like, cool, this is cool research, don't get me wrong, but like I use LLMs as glue between existing software. Like that's the best use. I use them to stitch things together. Like I use them to translate syntax. I use them to like do the monotonous stuff that I don't want to do. And then I have a workflow that is like much faster than it was before. And in part, but because of that, like all the steps in the workflow from like sophisticated tooling that's been developed over the years for specific use cases or specific domains, I'm like, I just leverage what's already been developed and then stitch that together. And then I can take advantage of what's vetted already. And that's sort of similar to what's going on here. Like the ontology structure, well-defined ontology structure is already vetted. Why would I reinvent it? I'm just going to stitch it together. And then I'm going to be immortal. Yeah, I think both kind of strategies are useful. Like I think we'll meet, we benefit from one another. But I definitely think more effort and what we'll be spending time on, more effort should be focused on using well-vetted anchors and then stitching those anchors together in a pipeline. Maybe that should have been the title of this class, ontology anchors. So let me say, or if you have any other questions about project 3, let me know. You can always just chat, like reach out. I'm happy to elaborate. You can hit me up on Slack or wherever. But right now I'm gonna shift gears slightly because I want to make sure some of the logical points that I'm talking about are
Should we do like
clear.
L2 reasoning now?
Yeah, so there are lectures up, Al2, Advanced Al, and Al2. I posted those. You're welcome to watch those at your leisure. Today I've got some slides where I'm just going to kind of highlight some subtleties of the reasoning that I think I've found that people over the years have a hard time internalizing, so I want to like hammer it in. And then I'm gonna make you do a hard problem. Or ask you to do a challenging problem. But I'm going to walk you through the challenge, like the first steps to the challenging problem in a way that I haven't before. Some of you have seen this challenge before, but I haven't walked you through in as much detail. I'm going to kind of point out some of the subtleties of the logic as you work through the problem, and then I'll put you in a position where you can kind of start finishing the problem yourself. So if you've seen it before, you're going to see a lot more of the problem today than you have in the past. So, how's that sound?
Good.
Hell yeah, let's do this. Okay. Dun, 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 dun. Hey, yeah, of course you knew it. But don't worry, it'll somehow be different. Okay. Super logic. So I'll give you a basic logic refresh. And then I'm going to kind of spoon feed us into what's known as to some of you, famously or infamously, as the zebra puzzle, which incidentally, nobody has solved. Nobody's solved this. 2 years. Nobody's solved this but me. Come on, guys. Ali claimed to, and I do not believe it. Basic logic refresher. Okay. So, first order logic is a very widely used formal language or series of representations in formal language. And first order logic consists of the following vocabulary. And every logic has a vocabulary. Every logical representation, description logic has one, OWL has one. And you can cache them out just like this. Now, first order logic, or in terms of what I'll walk through in a second, first order logic is like the granddaddy of logics. It's the big bad boy. It's too powerful for what we do. But ultimately, what we do when we're representing things in ontologies, it has to be compatible with, consistent with, conformant to some representation of first order logic. And if you're following something like the web ontology language, it will. And because of that, you'll have things like logical operators and connectives, predicates, variables, and punctuation. So in first order logic, you have things like the tilde, which means not, or the arrow that means if this, then that, or and the ampersand, which means this and that, or a lowercase v, which means or you have, because I got lazy and didn't put the ASCII in, an uppercase v, which for our purposes means all something. And then you have the E over there, which means something. Incidentally, do you know why it's called an ampersand? I guess in the UK, people used to sing the alphabet, and at the end, they would say and per se and.
It looks like a percentage.
Ampersand.
They also call it commercial and.
Commercial and?
Yes, because it's always like in brands.
Oh, that's hilarious. That's hilarious. In any event, not, if, then, and, or, for all, for some. These are the interpretations that are given to these symbols in the syntax, in this vocabulary. And this is, again, like a reserved vocabulary for representing things in first order logic. There's also predicates. You can relate things. You can relate things like P, You can say that something is pretty, for example, or something is round. You'll usually define what P means, and you'll give it a little space for a slot. You'll say P underscore can take one constant or one variable. John is pretty, obviously. John is round, obviously. And you can relate things. You can have two-place relationships, like related to. R might be a two-place relation that holds between two entities, saying that one is a relative of the other, right? You can go on and on and on. You can have ternary relationships. The relative of is binary, but you can have ternary relationships like between. X is between Y and Z. Federico's between Greg and Ray, right? Represent quite a bit of natural language doing this. There are also variables. Variables are restricted to use within the quantifiers, or at least being bound by the quantifiers, at least in the languages that we'll talk about. What this means is that they fill these slots. So all something, some something. And the variables work just like variables in mathematics. They just mean like range over the domain. They might also fill in slots for predicates, depending on whether they're bound or not. You can say something is a relative of something else. All things are a relative of something. Something is pretty. Something is round. Everything is round, and so forth. There's also punctuation that just helps us group logical expressions all together. And this is the syntax of first-order logic. Tries to make things expressive, very expressive. But here, let me walk through an example. All bald men are happy. This is a fact, obviously. Yes, we get a lot of sun. You can walk through natural language and paraphrase it into this language. You can do the same thing in description logic. Most formal languages are set up so that you can move from natural language into the formalization, and they have some kind of paraphrase strategy to do it, although it's not always explicit. I will make it explicit for you. Everything that is bald and is a man is happy. For every X, if X is a bald and a man, then X is happy. Plug that into the formalization. You can see for everything X, bald, variable associated with what is supposed to be an all, binds variables associated with predicates within its scope, like BX, like bald, and then MX, like that, right? And then, of course, in this case, all the variables are within the scope of that all, because we're talking about everything, every X, for every X, if it's bald and a man, then it's happy. And that is the expression. That's how you walk through. But here, more important than the syntax. Syntax is one thing. The symbols don't mean anything. I just gave you some like glosses in red about what they mean and a paraphrase from natural language about what it means. But ultimately, syntax doesn't mean anything. It's just shapes. But what does it mean? For that, we need an interpretation. Here's a way to think. I'm not going to go through like the details of interpretations on the formal side. You are welcome to watch the YouTube video where I talk about stuff like this, give you like interpretations of description logic, like formal interpretations. For here, I just want to walk through the subtlety of the interpretation, the semantics intuitively. So for every X, there are all the things, all of them. They're right there. It's right there. You're there, I'm there. Hate there's, love's there. For everything. If then restricts the domain to just the things between it. That's how it works. For everything. Otherwise, you're just talking about all the stuff. So you have to restrict the domain if you want to talk about something more specific. In this case, we want to talk about something more specific. In fact, we want to talk about the intersection of things more specific. We want to talk about things that are bald and men. Here are the bald things. You can just group them all. They're a subset of all the things, obviously. Here are all the man things. Not all men are bald. Not all bald things are men. There they are, right? Just aggregate them up. What we want to talk about is the bald man things. Out of all the things, right there. Now, if we restrict our focus to just this intersection of bald man things, what we want to assert is that it's within the scope of all the happy things. That doesn't mean they're only the happy things. Doesn't mean only bald men are happy. It just means if you're drawing these little diagrams, all the bald men things are in all the happy things. That's what it means to say for every X, if X is bald and a man, then X is happy. All the bald men are happy. That makes sense? Mm-hmm. Oh, yeah. We also add names to this language. Names like A, B, C, and D. Alex, Barbara, Charisse, and Denise. Right? Just names. Names for things. Names for constants as opposed to the variables, right? These are things that are associated with stuff in the world or stuff in the domain. These are like individuals, if you're thinking about it in description logic or OWL. Like Alex, Bob, Chris, and Deborah. Damn it. I almost got it. All right.
But one question, John.
Yeah.
Isn't it like the interpretation of A is Alex?
That's right. That's right.
Yeah. Yeah. So
Absolutely.
A is not Alex, but the interpretation of A is Alex. Yeah.
That's right. Just like the interpretation of that P underscore is like
Yeah.
the set of pretty things or the set of
Yeah.
perfumed things.
When interpretation.
Hmm?
But in this case, it could be a shortcut.
It could be a shortcut for sure. That's right.
You can write Alex.
Yeah,
Or
for the intuition mongering, for sure. So compare. There's a difference here, right? Someone is bald and happy. John is bald and happy. Both true. But these are different, right? One has uncertainty involved. The other does not. The second sentence, John is bald and happy. That entails the first sentence is true. If John is bald and happy, then someone is. Someone is bald and happy does not entail that John is. Think about that for a second. There's uncertainty. Existentials can introduce uncertainty. Quantifiers introduce uncertainty. Variables introduce uncertainty. This is important. The way we represent that, the way we kind of capture that in OWL or description logics is by introducing classes. Classes introduce uncertainty. If I said John is bald and I assert that, something is. If I just said there's a class of bald things, it doesn't mean John is. These predicates, is red, is bald, and relations, we can give them all sorts of names. We can represent all sorts of things. John has an arm and is part of John. You can say part of AJ, stuff like that. I have a sister, I do. Her name's Kelly. I'm related to her, unfortunately. Between Sam and Deborah, again, go through all this, but it's too powerful. First order logic is too expressive. It is undecidable. We can't determine for every sentence in the language whether it's false or we just haven't found a counterexample to it by using traditional Tableau calculations. This is what it means. It's undecidable. We cannot always be sure that if we are running a Tableau or a calculus to identify inferences and check whether one thing follows from another, we cannot always be sure that we can show when something follows from a set of premises. And because of this, putting it another way, it's impossible and hard, or it's impossibly hard, I should say, to prove every negative in first order logic. Now, we don't deal so much with first order logic, partly because of this undecidability problem. It's a boogeyman. And we don't want our computers to loop forever. And this is some of the motivation behind setting up description logics, which are a family of logics that are more restricted than first order logic, that are more restricted so much that they are decidable. And there are a couple of restrictions that you can put on first order logic that make it decidable. One, you have a finite domain. So in first order logic, you have an infinite domain. The other is only binary relations are allowed. So I just said you could represent in first order logic that something was between two other things. You could also represent that somebody has a hand at a time and then later doesn't have a hand at a time. I have a hand part at time one. I don't have a hand part at time two. You can say that in first order logic. You can't say that in description logics because you can only relate two things. You need that binary relationships at most in a finite domain. That's how description logics remain decidable. In addition, there are also names for things in the language. So just like the names we're seeing, like representations, like names. But importantly, the same object may have multiple names. So Fede has nicknames. I do too. They call me Buffalo John.
Well, I don't know. This is your
Denise calls me Buffalo John. It's crazy. But go ahead.
Does description logic allow for monadic predicates instead, or just binary like how?
Yeah. Classes are monadic predicates. Mm-hmm. So classes are monadic predicates, and then binary relations are object properties, or at least in the OWL vernacular. But importantly, they're under Turner relation. So again, I've kind of been hitting this point. Why care about the logic? Because that's what the computers read. The real strength of ontologies is linking parts of hierarchies to other parts of hierarchies, classes structures to class structures, and that allows us to draw on inferences. Let me give you some examples. Suppose I just added the term bacteria disorder as a subclass of infectious disorder. Don't worry if you don't know what these terms mean. I assure you that in my OWL files, they had axioms. So the machines knew. Suppose I just add that and I do it in Protege and I don't add anything else. The only thing a computer would know is that anything that's a bacteria disorder is an infectious disorder. You wouldn't even know that bacteria disorders have to have bacteria in them because I didn't say it. Out of the space of possible infectious disorders, we'd have this structure: bacteria disorder, infectious disorder. Cool. We certainly wouldn't want this intersection, but I have to say that. I have to assert that explicitly. If we don't want this to be allowed, we have to tell the computer no. We need to make these disjoint. You can do this in something like Protege. Again, remember what I've said about Protege. It's useful for teaching. I'm teaching. So you see a screenshot here. Bacteria disorder is a subclass of infectious disorder, disjoint with virus disorder. Right there, you can just assert that, click the button, make this disjoint. And here's here, if you're interested in seeing how to do it, click the little plus sign. You can write it in, and this is a sort of interpretation you have. No instance in common. Now check this out. I'm going to introduce an instance. Virus 1 and an individual, cell 1. And the first is a virus, the second is a cell. I do this to show you can use Protege or a tool that has a reasoner to check your work and protect you from introducing inconsistent things. I'll assert falsely that virus 1 has a cell 1 as part. Viruses don't have cells as parts. Viruses are acellular. I can assert this in my OWL file, in Protege. Here's what I'll see. Virus 1's a type of virus, which is a type of acellular structure. Acellular structures don't have cell parts, but I'm asserting that virus, this thing, is related to cell through the has-part relation. All these acellular things don't have cell parts. Don't have cell parts. Boom. Not great. You'll get an error. You should get an error. That make sense? Now, for the fun stuff. Check this puzzle out. This is sometimes called the Einstein puzzle because the internet seems to think he's the only person that could solve it. I think the internet is wrong. I solved it. I did it on a pad and pen or pad and pencil. The first time that I saw it, I will not give you that luxury. But what I will like you to do is solve the puzzle using logic. In particular, I would like for you to use Protege. I want you to use Protege to do this. It's a great teaching tool. Now, as you're downloading Protege, if you didn't already, or pulling it up, here's what I want. I'm going to walk you through some of this. So this puzzle has a bunch of assertions, logical assertions. They can be interpreted as logical assertions, natural language. And what I'm going to do is I'm going to walk through some of that natural language. I'm going to paraphrase it into not first order logic, because that's not what Protege reads, but description logic. It's going to have some similar semantics. I'm going to walk you through the pieces of the semantics, and you're going to see illustrations of how you might assert representations of these lines into the Protege editor. At the end of this, you've walked through 1 through 15 and modeled them, you will be able to click the reasoner, Hermit, something like that, and you will be able to answer this question. It will tell you who owns the zebra. And I know this works because I did it. If you punt around on my GitHub repo, you find it. But don't do it here instead. So you can solve this puzzle using just OWL, using Protege. And it's actually not you should keep this in mind because I remember what I told you. Using Protege for anything at scale is stupid and you shouldn't. This is not that complicated to represent in Protege. So if you find yourself going up in a balloon over representing things, you've gone too far. You actually don't have to spend a lot of effort or a lot of complexity in representing. Just walk through these sentences, start representing them Now, what does that look like? So here's some summaries, just kind of summarizing, and I have a note in the file. Each house is painted exactly one color, and what I'm doing, I just walked through here and I've sussed out some of the common structure. Every house is painted exactly one color. Each house is painted a different color. Look at how specific I'm being. Honestly, guys, I keep saying this is how you got to do this for machines. Like this is literally how I think. So just FYI, if you see the machine's not going to read this text. It's just like, this is how I think clearly, carefully, slowly, methodically. Each house is painted exactly one color. Each house is a different color. Each house is exactly one human occupant of distinct nationality, and exactly one distinct pet is owned by that human. Each human occupant drinks exactly one distinct beverage and smokes exactly one distinct brand of cigarettes. It's a lot of logic right there. There's a lot of keywords: distinct, exactly, one, and this helped guide my interpretation as I was representing these steps in analysis.
This is a big hint.
Yes. So check this out. I've got some defined classes: beverage, cigarette, color, house, man, pet. These are classes. They're defined. You can tell they're defined because in Protege, you'll see the little 3 bars. That means I've asserted some Al equivalent class. So these are each asserted Al equivalent to something. And why classes? They allow you to represent uncertainty. You know there are 5 men. You're trying to uncover instance level facts about them. Who owns the zebra? Object properties or relationships. Identify things like color of, drinks, drunk by, has color, home of, left of, etc. You'll see these represented here throughout from 1 through 15. Can represent these relationships between instances of classes using object properties. This will help us tease out assertions or like instance level facts about the individuals involved, whether it be men or pets or beverages or cigarettes. Some other things to know. I have color of, inverse of has color. What does that mean? Inverse of. If R is the inverse of S, then for any pair X, Y in R, YX is in S. You just flip them around. If X is color of Y, then Y has color X. It's logical. Did I miss one? Oh. Also, you can assert domains and ranges. You'll need to. Color of, the domain is color, the range is house. What does that mean? That means for the domain, color of X, Y, X must be a color, Y must be a house. Domain is the first thing, range is the second thing. This is important logical information. If I assert something is a color of something else, I just implicitly learned that there's a color that is color of some house because of the domain and range restrictions. You can also assert things like these role constraints like functional and inverse functional, and you'll probably do this a bit. This one in particular, because this asserts there's a one-to-one relationship. Both of them, functional and inverse functional. Remember what functional means? I mentioned it last time. So if a functional property is such that if X is related to Y and Y is related to Z, Y and Z are the same thing. So it's just X is related to one thing. Inverse functional is the other direction. X or Y is related to X and Z is related to X. Y and Z are the same thing. It goes backwards. So if you have both of those, one thing's related to one thing. In this case, one color, one house. Which tracks what I wrote in the note, 1-to-1. Just each color has, or each house has one color and only one color, right? Coffee is drunk in the greenhouse. I've got color of. See, you'll see these represented. Object properties. Insert the domain and ranges. Cools are smoked in the yellow house. So forth and so on until we get to instances. So we've got classes, we've got object properties. Now I'm on the individuals tab. I've asserted a bunch of individuals. There are a bunch of individuals that exist in this little world. You've got the color blue. You've got Chesterfields and dogs. You've got 5 houses and a Japanese individual and parliaments. I assume that's a type of cigarette. I think it is. And then T, but you also have the zebra down here. Well, I guess I could walk through this. The houses. You got the zebra down there. Note, observe. 1 through 15, at no point is a zebra mentioned. You have to put in something for the zebra. You have to put in an instance for the zebra. Even so. But at no point is a zebra mentioned in 1 through 15. Even so, there's enough information to rule out 4 of the other owners, or to identify 4 of the other owners with the other animals. So that when you get to the zebra, when the machinery like calculates through, it's like, oh, there's only one other thing or person left, and there's a zebra remaining, that person has to own the zebra. So even though zebra is not mentioned at all, a process of elimination, the calculation will show who owns the zebra. But to get there, you have to give the zebra in, or you have to put the zebra in the domain. Otherwise, that last person is going to own something, but we won't know what it is. You can assert this of green. You can assert this of individuals as well as classes, right? In this case, what I've done is not asserted of a class, but actually of an instance. Green. I'm talking about the color. And what have I said? Color. Again, you can do this right in the typing section of the individuals. Click on the individual tab, go over, click on green. You've got it in your domain, and you'll see type. Typically, people will just like say it's a type of a certain class and be done with it, but you can actually type out what I've just written here in that little box. And what is that? But you've essentially added a class structure, a complicated class structure, right there in the Protege. And what does it say? Color of, we know what color of means. Green is the color of some X, and I'm looking at 6 here. The greenhouse is immediately to the right of the ivory house. Green is the color of something, and since the domain of color is colors and the range is houses, it follows that X is a house. Right? Remember the domain. Green is the color of some house. Where that house is to the right of something. When you see a parenthesis like this in the syntax, you're introducing a kind of a existentially or a universal clause. You're introducing a variable. You see that because right before the parentheses, you've got some. It could also be only. But right now, we're saying color of something. Parentheses introduces a variable. The variable is picking out everything in that parentheses. So something that has all those features in that parentheses. That right of some has color value either, all of them. Some X is corresponding to that. If you're coming from the CSC, this is just list comprehension. That's it. So like just gathering up the individuals that would satisfy this as a list of things. That's it. So where that house is to the right of something, and what do I have? Right of, inverse of left of, for sure. Has domain house, has range house. I've asserted this. I had to. Houses are left of, right of other houses. I also asserted it's functional and inverse functional. Why? Houses are related to houses. They're next to houses. They're left of, right of houses. Now, where that house is to the right of some house, that is I. Altogether, green is the color of some house X that is to the right of some house Y that has color ivory. And I asserted that again of green. Now, I'm going to bring this all the way back to the beginning because I have a feeling some of you guys are going to ask me some questions. Okay, we already got one.
Just for the interpretation about the word, are the houses in line or in a circle?
I think the standard interpretation is that they're in a line, but that makes trouble for that one-to-one thing. But it actually doesn't matter. So you can think of them as in a circle. Yeah. And the logic plays out the same. Turns out.
Well, if they're in line, there are two houses in which like there is no right of relation.
That's right. Turns out that won't matter because that's not actually used in the calculation.
Yeah, yeah.
But it so basically what Fede is saying is if you have like functional and inverse functional associated with left of and right of, you are interpreting the houses as in a line like 1 through 5, like on the side of the street, then that won't hold for those houses. So the other interpretation is that they are in a circle, which would allow you to have this one-to-one relationship. It turns out if you crunch through the calculation, the left of right of never even touches the housing like order.
Yeah.
So it's okay to assert what I have, and it's okay to interpret them as being in a circle. Yeah, but that's right. Which is good because otherwise this would be a little bit more complicated if you had to abut to the edges. Any other questions? Mauricio just walked in and was like, what have I done? What am I seeing? He's like, oh no.
No,
I've made a terrible mistake.
Translate these and solve the puzzle.
So yes, I'm curious if you could, no, because this kind of it was a nice thing to try to
It's
let's
doable.
but
Just missed my whole spiel.
representing that, could we calculate automatically this kind of I never tried.
Literally just,
So-
yeah, absolutely. Absolutely. I just walked through how you represent some of this stuff. So Fabricio wasn't here. He just walked in after the fact.
You gave away so much here.
I did. I gave away a lot, but all right.
I mean,
Your
last year
turn.
we couldn't like, as far as I remember, like drinking tea might be just one monadic predicate. Who knows? Like you decide.
That's right. I gave you a bunch of breadcrumbs this time. So go forth, do your thing. Work in small groups, talk to each other. It's a hard puzzle. Nobody solved it except for me. I don't like being alone.
I don't remember everything.
Where's my dad?
Better.
We always work in one big group.
No, I still got into it. So we see different solutions. The good one and the bad one.
The right one.
Yeah.
I guess yes.
So for the folks that are online, or is John going to put us in another room or?
Would you like to be? I can do that. I mean, you could just talk here if you want.
Yeah, we can talk here too. I think it'd be helpful if somebody can share. Somebody can share. Yeah, I don't have.
Yeah, I can stop sharing if you want.
Okay.
You should probably take a picture of this though, just if you haven't already. That way you.
Yeah, I got pictures of it.
Okay, got it. So I'll stop sharing and you should, let me see if I need to give you. I think you should be able to share multiple. Okay, here we go.
Even after class.
Yeah.
Even after class.
Okay. Yep. I think I can.
Oh, you're using Protege.
Yep. Okay.
I know that.
All kinds of stuff going on my screen. Sorry.
Or you asked. Yeah.
But what is it? What is
Okay, so I guess we got Sane and a couple other folks on. Let me get my desktop organized here.
house was a defined class?
Yeah.
So when you make that axiom, when you have a defined class, you would put like the equivalent to axiom.
Yeah, it should be,
Like what is
I guess that if you're doing Protege, keep the profile with the owl.
Okay, so I guess the first thing for this is just to
like that axiom be like what is house equivalent to?
just to build this stuff into OWL. Um, John already gave us a whole bunch of
For example.
answers. I don't need to upload BFO or CCO or anything, right? This is
Nope.
just OWL. Okay.
It's just straight up out.
All right. So OWL thing, Control F.
So
for instance, for class, can be
all these are other actions about the color, about the inhabitants,
house of
position,
land,
because it's right to. These three things make it a class that is house.
So I can see you moving. I think you're on mute, Sane,
Me?
if you're trying to talk.
Yeah, I was.
You wanna do
Shall I type maybe? Is that an ID?
So all I'm doing right now is just typing the classes in the Protege. If there's a better way
Okay.
to do this,
This is
No.
also what I'm doing, so I don't know a better way.
I guess it could. How do we divide up the work? Oops. And I am not, let's see. I'm not the most proficient at Protege.
I mean, in a way, if we're with four people, we can all pick four. Um, we can all pick four sentences and all. No, that doesn't work.
Yeah, we do need to put it all together.
Yes,
Yes.
yes,
Yeah.
yes, yes. Yeah.
Otherwise, it doesn't solve it for us.
Yeah. Yeah. Let me see speed wise.
Oh, do you guys not take pictures?
It's on Wikipedia.
It's on Wikipedia.
You just search up
Yeah.
zebra puzzle.
Yeah.
Damn, I got here. I got all all the entries. Like, this is the shopping list.
The search engine of GitHub is like that.
There should be a chat GPT solution to this, but I mean, it means like sort of you don't need to read the sentences. You can just copy it from the.
Did you put it in the chat?
Yeah.
Okay.
Yeah, I don't think I can present at the same time. Um,
So I'll let you present then if you want to do that. Let's
oh
see.
yeah.
Just stop sharing. Oh, okay.
Let me get that. Yep. Share. And then I say advanced, no basic. Use system window capture, probably.
All right. So
I don't know what happened. Do you see something?
No.
No, you don't see anything.
See you.
Yes.
Okay, try again. No, this is sharing my whole screen. That's not effective. Share. Use system window capture. Should be.
okay.
Yeah.
Annotation.
Got it. Now I
So
just need to get the right screenshot. Share. Sorry about this.
There you go.
Yeah, this should be it now.
okay, so Is there predefined owl properties, color of, drinks, drunk by, or is that something that we're in?
You
Because I
gotta
mean,
make them.
Yeah, we're
okay.
just gonna throw them in there. In mine, I've done each property and its inverse. I don't think that's necessary probably, but it might be nice to have.
I can put the properties also in the chat, by the way. So if somebody's typing in the properties, I do have those too, if that helps.
And that would be under the object properties tab, correct?
Yeah,
Under entities. Okay, yeah.
yeah. I mean, in a way, there is a turtle view, so you can say, "Hey, show me the turtle," and that can be cut, copy, paste to the chat. So then it is possible to merge these things.
Sorry, go ahead.
That house.
Don't read it, right.
Please.
That house color.
Yeah, so here
It's okay. It's okay. You can see it. You're like,
is,
eyes that are like 30 years younger than mine. You can see it.
Leaves surely is a kind of predicate that is binary because there's a other option, right? But you have different options, same thing, which one it could be like human one that is an Englishman.
well, because of the screen sharing, this now all looks different. Where is the chat?
Right? Like two ways of name plus the predicate English. So you can just have E1 English. Okay. So which one do we use? Human one that is English.
Oh, yeah. So that needs to be a predicate.
I don't know.
That is.
We have to decide which one.
Oh yeah, it got somehow.
There are many.
I guess you would need.
Yeah, so these are all the
I feel like you
object properties. I put them in the chat.
So since there are many houses, there are many things that are houses. So I would say there is a class of houses.
Yeah.
Because if we had just one, maybe you could just get by with one element that you call H1. But now, yeah, so house is a good universal.
But the goal is just to solve the puzzle, or
Yes, who owns the zebra?
And then the purple diamonds, what are those? Those are the
Or
instances, right?
Instances, yeah,
Okay,
absolutely.
all right, got it. All right, so add a sibling class. Okay, individuals. Add an individual. Let's see. House
Yeah, maybe
one.
because not good enough.
Cancel. Okay.
I probably five for everything. Right?
Well, they ask because
that can't be right. Because it's wrong.
yeah.
All right. So now I'm trying to figure out how to associate house one with the class. And it's not an annotation, it's a type.
Yep.
Okay, there we go.
So
House.
that's the Englishman instance of human.
Yeah. You might be able to do it faster from the classes tab if you just like write in all of the create all of the individuals, then go over to the classes tab, and then you can add instances to the class.
True.
Ah, okay.
Yeah.
Good point.
Oh, Ukraine.
Yeah, the drawback of this is that um, the classes are not grouped. So Sam, maybe I can help out by sort of slowly mentioning sort of the colors, or anyway, if you indicate where in which class tab you are, I can start calling out those instances.
Hang on. That'll be helpful in just a second.
Either a beverage or food. That's fine.
No,
No, because they.
I think it's final finish.
Okay. No, because aren't there, how many?
Orange milk.
No. This beverage. Because this is one of the
These ones.
then there would have to be some sort of.
Do you have to have an underscore for every time there's a space?
Or
I think so.
I think it does it automatically. Yeah.
Oh, I'll put them in
Uh,
myself.
yeah, that's what I'm doing. I'm putting them in myself. I'm gonna try it next time. See if it adds it. It's a couple less typing strokes.
But then the other thing we consider is that.
The cigarette brand.
What?
The cigarette brand.
Yes, but.
And it does add it itself.
I'll probably save me a little bit of time. Good to know.
So I'm saying like. There's a thinking. For right now, put that to the side, but the way. Then there's another slide, another category for cigarettes. So there's.
John, where are
an
these
option
slides?
with the open slot where we have
These
two
slides
options that there is no
are on the Info Academy. They're under Logic for Ontologists. They are under,
but I'm just bringing it.
I want to say it's lecture 6.
But I believe.
Yeah.
No, well, because New Art says that the doesn't work with the brain or doesn't
Okay.
just you know search the thing
I guess something like left of asymmetric and reflexive, I guess, right?
No,
I don't know. The
Reflex?
characteristics are
No, left
confusing to
of,
me.
you cannot be left of yourself, I think.
Right.
Okay.
But it is transitive.
I don't know, at least.
Hmm.
Does that make sense? Yeah. I wasn't thinking about it.
And it is, I think,
So, right now.
asymmetric.
Yeah.
I agree. I think it is asymmetric.
And transitive.
You don't think
I
it's
actually,
reflexive.
for the purpose of the puzzle, I don't know that we want to define it as transitive.
That's right.
Because look at number 6, right? We're talking about immediately to the right of the ivory house.
True. No.
And some of the other things might be problematic if we make it transitive. Or am I?
Yeah.
I'll
Yeah,
take your
indeed.
word.
True. True.
The characteristics are the thing I think I get the least.
It's okay. Protege doesn't do a great job with them either.
Wait, so what is reflexive?
The devil.
Okay, good to know. So I'm just gonna uncheck it then.
Yeah. Don't ever use reflexivity. Ever, ever, ever in OWL. It just breaks everything. I have a whole series of rants about it I could direct you to, so I won't belabor it now, but for this purposes, don't reflexive anything.
I recall in a course you ranting about one of them. I didn't remember which one. Good to know.
Absolutely reflexive. Absolutely every
Yeah.
time.
Sam, so I still iterate some of those entries for you.
I'll be right back. Give me just a second.
Yeah.
I gotta do something.
That's what I'm saying, is that, already instances of policy. How do we want to represent it?
Let me otherwise give it a start.
Red. Like a red house. No, sorry, the red house.
How do you think?
Twice the I think so while immediately pick an arbitrary house and just start from there. Or because I can probably see the time that confusing. Yeah. So
What do you think about refined red colors that have instances for each color?
that'd be the other option.
The other option would be like having classes for type of
red photo.
Do you need a password?
You don't have box red. You just have one red. You have one color.
How many Englishmen do you have?
Yeah, right.
Yeah. That's like tailored to this problem, because if you expanded the problem with further sentences, maybe the circularity of the houses or having nationalities for people.
Or just write of as transitive in general, but probably not the best thing to do here.
And another thing is we have kind of a code
Deeper roots.
to express that okay, you must drink one of these beverages. And just one of them and all of them are still.
Right. That's how you get the reliever, right?
Yes.
There's somebody has to, there has to be a one-to-one relationship between somebody owning something. If you rule out 4 of them, there can't be any others. There can't be 6. There has to be 5. It has to be the zebra. It's closure.
That actually all the things that is this that go to this west. But about some the way to do that is like put to the class by invasion. This the class of this thing. Yeah.
Enumeration, which basically you just list all the elements.
Yeah.
You can do that in there. You can say like color is L equivalent to the red or blue, or and that's exactly how you wrote it. Red or blue or green. And I think I'm sure you saw me. You see me talk about enumeration and what it means. It's like a linking or is linking sets of things, and so or becomes a singleton set. You can equivalently write it as bracket red close bracket.
Yeah, Sam, I don't know if you're still on, but I put in all the data.
But it's simply
Or anyway,
and it's a company, it's a class. So you saw those 3 little bars. That was what I said. That provides the closure that you was talking about. Because it's like it's one of those, but it's one of these 5 things. That's what color is. It's one of these 5 colors. This one or that one or that one.
Okay, I am back.
okay. I put the data in the chat.
It is another organization out of Anchor organization. Why do you have 2 organizations?
It should just be the same organization. I just must have included.
Oh, I mistyped Ivory. Yeah.
Maybe
Shall I just do it, Sam? Because I got all the data here.
Yeah, I'm looking at I'm on the class man. Oh, okay, never mind. I see it. Got it. Englishman, Norwegian, Spaniard, Ukrainian.
So you use logic for ontology 2024 for these slides?
Yeah. I did add some stuff.
Okay.
This time. But I can just put these slides on the side. I'm gonna put the slides on the Slack, so y'all have them.
Yeah.
What?
All right. There you go. I'm just doing some quality checks to make sure I didn't miss anything.
Got it.
I only have 4 pets, but I see 5.
Dog, fox, horse, snail, and zebra.
Dog, that's what I'm missing.
And eventually you can always add red as a classic relator, and the red one is one of the instances of red.
Could say it's from the way I could just assert X red argument class. The way that
Sorry?
here, like I didn't assert that, so it's just an instance.
Yeah, it's good. You can
I'm
start
on
with
to trying to add these property assertions.
you add this instance to the class, right? Surely you have an instance. Instances must be there.
So I just got the.
Yeah, I'll type in the
Are you sure? Okay.
predicates also.
Sure, perfect. We don't know if we need.
Invalid individual name. Well, I made a mistake somewhere then.
I thought that we would need human class just based off of that competency class.
Okay, that's great.
Water.
Sometimes it's just like we run the thing. I know it's like certificate data when we need evidence, but let's try to parse it in a way that we are sure that enough is covered. So things that are completely
Okay, I got every instance associated with the class now.
Okay.
you know that must be a relation.
I'm at the same spot.
Owning, drinking, because
And I have here the
so that's for sure. But you cannot get away with an individual with drinking.
relationships,
Oh yeah, yeah, I gotta put the did I get the relationships in there?
the data properties.
Let's see, data types, no, data properties.
Yes, you're just looking at the syntax.
Okay.
Yes. When you're done with something,
So somebody gets it, everybody.
you I don't know, you highlight it.
Yeah, could have.
You know,
Oh wait, does it go in data properties or object properties?
you don't have to cover it more.
These are ins
I think
And
object.
color of, drinks, drunk by.
object properties, no?
Yeah, I
Okay.
think that's what I was using at least.
Yeah, that's what I did too. So I have okay, I got object properties, classes, individuals. So I think those are all the,
You even talk about
That should be everything we need before axioms.
yeah. Okay, and we got everything. So we got it under the right, presumably the right thing. Object properties, classes were the only one that was kind of questionable was the properties, but I think we're good.
Here I got a new. Now I sort of. I put the properties in the chat, but I group them now by inverses.
Do you have any recommendation
Works a bit.
about these like extensions in general and unary extensions and binary extensions? Because Alan mentioned that last week about common logic that doesn't
Yeah, Protege orders is really weird.
understand. That is
Yeah, I found that in the end,
some of the power of second order logic.
if I do sort of the first statement in Protege, I copy it to the text editor, boom, you know. So like, for me that works.
Anything by Chris Menzel on
Chris Menzel.
Menzel.
It's like John said, if you use Visual Studio Code, it sort of checks the validity of your RDF file. And I think you can even get, if you use VFO references, you can even check if the reference is valid. So it does a lot of the heavy lifting in Visual Studio Code.
He talks about
Just a quick question. Whoever's got the Protege up on their screen, could they share that instead of the zebra puzzle?
this is pretty well known.
Yeah, I don't have it open because I thought maybe we make one file and then share it, but I can definitely stop
Introduce
sharing.
Stop
sharing. Stop sharing.
That's a way to simulate.
What's a sort one?
So you have like you segment off at the meta level, where things like individuals and time.
Well, Zoom does not like Protege, so I have to share my screen.
I think I crashed my Zoom.
Where you like say, all contradictions, or there are no.
Okay, you should be able to see Protege now.
There are two types of.
I can see it now.
Yeah.
Thanks.
Then there's a translation of
all right, so what's the first thing we need to do? We need to now is where, since I got this full screen, I think start building axioms.
The sorting is you still have to spell the domain like that.
Well, we can build axioms out of some of the things from the zebra puzzle, right? Actually, wait, before we do that, it might be good to order the houses.
Yeah, I said I did first.
When you say order the houses.
Well, go to the individuals.
Okay.
So we're going to go to house one.
Yep.
You're going to want to say that the houses, like, I think it'll be easiest if we imagine they're in a line. So we want to say that house one is like to the left of house two is to the left of house three,
That's
etc.
exactly what I did.
Okay.
Yeah.
All right. So that's gonna be
Yeah, so you'll go to types, I think.
Yep. Oh,
Or
I
yeah, no,
did-
you do it object property
Yeah,
assertion.
that's what I did.
Better, you're right. Yeah. And then you just assert all of those. We will want to do something in the types though to make sure that you can only be to the left of one house and to the right of one house at maximum.
okay.
So here you would just do like left underscore of and then house underscore two.
Yeah. That's to start, yeah.
And just go down the line to the last one, or to 4.
We also add house 3 as the middle house.
We do that all the time.
I don't know that we have to add that house 3 as the middle house explicitly.
Isn't it already explained? Like if everything's left of one thing, wouldn't that naturally just be the middle house?
Exactly, yeah.
Okay.
I
wasn't sure if the reasoner could do that.
Well, the reasoner won't make an assertion about what's in the middle, but if you rephrase the question about like you could make a class which is like house which is to the left of one house, which is to the left of another house, and which is to the right of one house, and which is to the right of the other house, then the reasoner could easily answer that question for you of like what house is a part of that class.
It came out when I was grad student. I read it, but
do we want to say house 5 is left of house 1 or no? If we said the
No,
line, but
no, because it's not. Yeah, in a line
okay.
it wouldn't be.
All right, got it.
The hard part is figuring out how to characterize this.
By the way, if you hit Control Space in that
You can assert what kind of
object property thing filling, then it auto fills.
but then like formally.
Okay, so I got the houses ordered, house 1 and house 5. House 5 is the only one without an object property assertion.
Yep.
So far. Okay, so then we go to types, or are we?
I think from here on we just need to do every sentence known the zebra puzzle.
Okay, all right.
So that's what happened when that substance.
Sorry, we do need to do the sentences of the zebra puzzle, put object property assertions and types on the individuals, but we'll also need to go back to our classes in order to get some of our assertions off the ground. Because right now there's nothing that prevents like all of the classes from being applied to all of the individuals.
Oh
right?
yeah, the domain and the range.
Yeah, exactly.
So we want to make sure that there can only be we want to make sure that each class can only have one instance.
Yeah.
Well, no, sorry, not only one instance, right? We only the instances that we have, but they should be equivalent to some other things. Like, for example, the color should be the color of exactly one house, right?
Trying to say.
Let's see. Well, it wouldn't be that. That's not right. Equivalent. Where's the domain and the range?
I
Target
don't
for
know.
key.
Go to equivalent to again. This should be
whether or not.
So
instead you should go to
yeah, you can
the
have
expression editor.
yeah.
Is that if
They
they
all work the
start
same way functionally.
No, no, that
But
one more to the right.
Okay, got it.
Yeah, and now we just do some Manchester syntax, where you'd want to say, what's the property we use for something that has a color?
he does a really great job.
It's has color is
Okay,
the
so yeah, then you'd want to type in has color exactly one house or something. Oh no, we're on pet right now. I'm
Yeah.
silly.
Has
hang
owner
on.
exactly
Let's go
one.
to
But
house of color.
like
I think there's some
Like,
House or color.
go to either one. I just should have been paying attention to which
Yeah.
class you were actually
No, I was
on.
on the wrong one. Okay.
Yeah, but
So
then
house has
my concern is that
color.
Chris is
Exactly one.
going through his time. He's
Now
like
I'm
using people with
coding and some of the other stuff is my weak spot. So Manchester syntax is
it's just a way, it's a notation for logic that we use in Protege, which is pretty easy for humans to look
okay.
at. So like you just when I tell you to type something and you just type it in English, except of course instead of typing out one, you would just use the Arabic numeral.
like
Okay.
listen.
Yeah, it is. You can also think of Manchester syntax as a variant again of Turtle, but then even more natural language. Like XML is really hard to read. Turtle you can read. Manchester tries to be really English.
Yeah.
Got
Although
it.
I think Manchester is actually kind of misleading, frankly, because I don't think it does I think it is misleading about what the nature of the quantifiers are, but that's just me.
This is a perfect Sam.
So exactly one. All right.
Exactly one. Yeah.
What we do is
That's
That's
what
it.
we want.
Yeah.
Well, no, it has color exactly one, and then you need to specify the class of the thing that it has exactly one of. So you'd say exactly one color.
has types like this. There's a span.
I think it might. I didn't think it would
Uh,
fill that in for you.
I think has color needs to have a range of color.
It
Yeah.
should, but you also it only no, it only gave a problem for color when you wrote it in because you did not capitalize the C because that's the name of the class that you defined or the
Oh,
yeah
okay.
right. Yeah.
Got it.
It seems like the name of
Oh, like this. Okay.
Okay.
Like if you set your source.
Any other thing for house? Or are we good? Do we need to do
Now,
anything with the order?
and is owned by
So that would be
exactly one man.
Yes.
Okay.
And then if you do this sentence in parentheses, just for
Well, it said this. That's more sense of how these handle things. Because he wanted to. When I was working on this, I had the source.
What do we use for the property for ownership?
I wrote owned by. I don't know if you guys have the same one as me though. I think I copied it from the screenshot.
owned by exactly one man.
You might also have used owns. I don't know.
Yeah, that's why I said I would check because I copied the screenshot, not your guys.
The trickiest part for us was that, and I had done this.
This keeps damage is water.
I had created
Is it not picking up? WN by.
What you also can do if you take the by out and then hit Control Space, maybe it will autocomplete.
An owl from the clip. That was where I left off. I was like, I was able to arrive on
No. Since actually we got into sort of like because you didn't mention that.
Yeah.
Protege does not like me.
No, but so if you do the first sentence in parentheses,
Okay, this is new.
Yeah.
yeah, the second sentence too,
That's fair. Okay, so we have 1, 2, 3, 4, 5.
and then you start the second sentence with and
Yeah.
Outside of parentheses.
outside of the parentheses. So now you have to, yeah.
There we go.
And now it parses it, and now the owned by is also good.
Okay. All right. Any other, so it has exactly one color and it's owned by one man. Do we want to say and it only has one pet? That's the assumption, I think.
Well,
I don't know if that's true.
do you want to connect the pets to the houses or the pets to the men? I think is probably what
Yeah.
we
Yeah.
I think
Okay.
man makes more sense.
All right.
Yeah.
We can.
Although it would be interesting to ask, but that's more like, hey, could you catch everything in one statement?
So we put everything in
But yeah,
Okay. So we can come back to that thought
yeah,
maybe towards the end if we
yeah.
get that far.
triangle
All right. So
to the next, and
class expressions. So two class expressions. Okay. So there we go.
That makes.
All right. What other class expressions do we need? The cigarette is smoked by a man. It's drunk by a man in a house. Like,
Beverage drunk by exactly one man.
give me a
So now, yeah.
I'm teaching it for, so.
okay. So what do you translate this for?
Can I come in?
So far, I have.
so it goes object property,
Okay, so what
Predicate.
predicate.
So
I have the Englishman living in the red house, and then I have the red house defined as the intersection.
so for whatever you've already translated, I put
Exactly.
If you need the parentheses, I think it adds it itself if you type it properly. I think it did when I did it.
Well, I'm assuming I started out with the parentheses just because of if we're gonna add more than
Yeah, it doesn't hurt.
yeah.
one individual in the red house.
Because I have red and red.
Yeah.
Okay, so now we have to make a decision.
Let's see what else for the
Yeah, house is already an individual.
I think this is fine.
But he's red.
But yeah, I don't think we have any other assertions or
Okay.
properties, rather. That would make sense.
Isn't showing up. It's supposed to show.
You
all
like
right, so
cigarettes.
beverage. What did that just do?
Yeah.
No.
Oh, you can probably copy it
Yeah.
House is things. Because it's
or not, I guess.
5,000. You have to count them. If you have to count them, you need individuals. So this is important thing.
Yeah, you have to do O and then
You can do
cut it
red house or
and then delete it.
option
House that happens to have the color.
to have the color. Perfect. So like have color house, and then what do we have here?
Okay.
Yes.
All right.
And
The cigarettes. What do we want to do? What do we want to say for the cigarettes?
Yeah, it's not the.
That doesn't now.
It's not
Yeah,
the
smoked by exactly one man.
That is true. Yeah.
one and house one.
Never did that.
House has color red one.
I think
It's
I'm
possible.
not sure.
It's a universal.
Anything else we want to say on this one?
Don't think
Not on
so.
the class, I don't think.
Okay.
Like a troll.
Yeah, so like.
Color.
Legit possibilities. So which one do we pick?
Do we want to do an inverse, or does the inverse of the color
I don't think we have it, no?
belongs to one house, or are we good because we said the house has exactly one color?
Or like color of. You can say color, color of exactly one house.
like,
Color of
Like this.
exactly one house.
If you have
well, I guess
necessary conditions. So
house.
everything.
Yeah, right.
Sometimes you
Okay. House has exactly one color. Man.
there is a class in the language.
So we would say we want to say lives in or owned by. We said owned by.
So not owned by would be
Owns.
the inverse. Yeah,
Oh, the inverse. Okay.
I think we've moved past that in today's day and age.
Oh,
The red colors and these
And if you are
not very good.
oh, I
So it'd be like owns exactly one house and owns exactly one pet and owns exactly one beverage and one cigarette.
5 houses, but we don't.
Does a man own exactly one of everything here?
I think so.
Yes.
wait. It's lives in home of a house and owns is for the pet.
Oh, you're right. Yeah. That's correct.
Let's keep in mind
So
that
lives in.
Yeah.
there is green. So there's another house
Yeah.
that will be green.
And a house with a capital.
Color class that will be a class with subclasses of red,
And what we say
stuff like that. Which instances
owns exactly one pet.
Yeah.
I'm saying,
And do we say owns beverage as well, I guess, and cigarette?
Drunks
Drink.
buy or smokes.
Oh,
We
yeah,
don't.
yeah, true. Okay, yeah. Drinks and then smokes.
It's
Yeah.
drinks.
But if we define reverse relationships, we don't have to double, huh? I don't know if we did double, but
it's a house that happens to have a color. Because we
Exactly.
have the five
One
houses, we have them as individuals, but we don't know, we can't say
beverage.
house one is red because we don't know
So the
that.
dog.
Oh, well, we don't know if house, well, yes, that's true. It would be, we don't have this assertion. I completely agree. We have, to be
And
fair.
confirm you do not need parentheses, just so you know. It's just
Okay.
So whenever you have, perfect, this is another good,
I
thing.
already did it, so I'll do
well,
this one.
sure. I'm just saying for
Yeah, yeah.
future reference to save you time.
One house drinks exactly one beverage and owns that's it actually, right? We got three there. One, two, three.
Of this domain.
I have drinks
yeah.
exactly one beverage, lives in exactly one house, owns exactly one pet, smokes exactly one
Oh,
cigarette.
okay.
Whenever you have
Smokes.
But the smokes should already be defined on the cigarettes now.
Probably. Yeah. I mean, yes, smoked by exactly one man. We probably
Yeah,
did that
so
multiple times, actually.
yeah, I don't think it hurts, but I
when you
think
have
for bookkeeping there is probably
and the
some
rain.
preferred way to.
I would imagine it's probably the simpler the better, but oh well.
All right.
Yeah, because on the on the object properties,
For example, but everything that is
What do you want to say the pet
red,
belongs to? What was the property?
they would, this is like,
owned by,
Yeah, I don't think
unless
we have a separate one. It would just have to be owned
Okay.
by.
yeah.
No.
Which again,
I would do,
assuming what you guys are saying are right, since we say owns exactly one pet and man, we probably shouldn't need to write that there, but probably for our sake, better to write everything just so we know we're doing it right.
Yeah.
it's easy to lose track indeed, but I think for the data properties we should mark the inverses. I don't know if you did that.
I have not done that yet. We
Uh,
just tried doing the class expression
yeah,
editor. Do we want to say lives in one house for the pets, or are we good?
I don't think
no,
so.
Okay.
I
All
don't.
right. Okay. So we got
Oh,
equivalent to, we got at the class level, we got
and then the rain.
drunk by, we got an expression for beverages, we got expressions for cigarettes, color, house, man, and pet.
drinking must be,
Okay.
Then I would do the data properties
as I said before. So we
thing.
would over.
Oh, yeah, and then it.
Oh, sorry, the object properties.
There's a lot
My
of
bad.
uncertainty here. There are so many things that are not.
No, I don't want to do that.
Over things that are
What did I just do?
Entities,
There
yeah.
we go.
You have a split here.
And I think entities, data properties.
But we already know all the other things, so.
Yeah. Oh, sorry, object
Okay.
properties.
All right. There we go.
Yeah,
Okay.
so everything is functional and inverse functional. That's where it starts. That's the top two and the characteristics. Yeah, functional and inverse functional.
It's the first, yeah.
And then the inverse of is color of, has color.
So it's a good pathway of translation, right? Do you think?
Yeah, that's.
And this is just all the way down.
Perfect.
But
So domains and ranges. So the intersection. So the range would be the inverse. So we want to associate it with the house, right?
true.
Well, yeah, the range of has color will be the color actually because it'll be the thing in the domain has the
Domain
color.
is house, I think.
Domain is house. Okay,
Yeah.
got it. Yeah, I get the domain and range confused. Did that take?
Yeah.
Go back to there. Okay, there we go. So the domain, the range is, and then the range, we have to
Color.
define that too. Color. Okay.
So right now I'm doing the span for the
Okay, so
Okay.
what do you think is a binary relationship here?
Oh, so if you have.
Okay, then we will cover.
Do we need to do anything else on this one?
Yeah, the drinks.
Yeah, no. Okay, so we're done. We're good with color
Yeah.
of. All right, drinks.
Yeah.
Functional, inverse functional, equivalent to.
Oh, no, sorry, inverse of.
Yeah, sorry. Yep.
Drunk
Inverse
by.
of
You can skim through.
Yeah.
by.
You can
Okay, the domain is beverage.
focus sometimes.
No man.
No, domain is man. Yeah, backwards again.
Oh,
Yeah, like we can, yeah, we can.
Yes.
Dynamic relation.
range is
Beverage.
beverage.
There you go.
Information to understand.
Okay. All right.
This is good. You don't care about the task. Well,
So,
That should be inferred. That should you
yep.
can click, but
And
if
next would be
you
home of,
if you
because,
start a reasoner, then you can see that it already filled in.
yep, I can, it's already bolded to the first four. So I think
care about time.
home of would be next.
Drinks. Oh, well, if drunk is the opposite, so we'll have
Let's see.
is drunk.
Said we wanted to make everything inverse functional and
Yeah,
functional.
but I think if you start
Yes.
a reasoner, it fills it in automatically.
Relation so far, but then
Reasoner, let's do home hermit. Where's run reasoner?
can you tell me
Yeah,
about
sorry, a reasoner start. So if you go back to reasoner,
It's just the top, yeah.
start reasoner, yeah,
And it'll like fill in anything that it reasons.
Okay.
yeah. So now you can click around to see because anything that is reasoned is going to be yellow.
Then we define the mean.
No, it didn't.
Not
It
reasoning
didn't.
a whole lot.
It
No.
didn't reason anything. No, that's surprising. I thought it would fill it in.
Hooker? It might be like a unary relation.
Well, part of the problem here, right, is that the reasoner, when we're working in OWL, right, we're working off of the open world assumption. So the reasoner doesn't go on its own and say, do deductive reasoning all over the place. I mean, well, I guess it is deductive. It just if there is something that is unsaid in our model, the reasoner will not make an assumption about whether that's true or false, right? Or the
Yeah,
whereas when we're looking at this sort of problem, we're like, okay, we're gonna do deductions, and the only things that are true are things that are said or that we can derive from stuff that's being said. And we might need to make some more things that are implicit, explicit in our model, I think.
We already know.
yeah. But I would think if I say that has color is the inverse of color of,
About cigarettes.
that there is no two ways about it. That's what I would.
We are not trying to represent the whole world. It is true that in
But
the
yeah,
Right.
real universe.
Well, let's go look at the individuals. Let's
yeah.
see.
Control R to sync. If you hit Control R,
That's true.
then it reruns the reasoner because the reasoner doesn't run automatically. Yeah.
Nice.
So now you see in the right corner reasoner active. That means everything is cool.
No,
If you type something, it's going to say something like out of sync.
and we don't.
And if you made a mistake,
are looking
it's
at
going to
the-
sort of say like, oops, it's inconsistent.
Because this will be easier. Don't imagine
But you're good here.
you're not.
Okay. So we're going to individuals now.
I think we should still check the inverses.
Okay.
'Cause-
All right. So drinks by is the inverse of, or drunk by is the inverse of drinks.
yeah.
So do we need to assert domain and range, or is that covered because we already did drinks?
Yeah, so it looks like we need to do it. Because otherwise in yellow it would say so.
So
Yeah.
drinks. So the domain
Man.
is the man.
You just said.
The range is beverage.
Cigarettes.
Okay.
Are the domain.
All right. Has color, inverse of color of.
Right here.
Yeah.
So color of
No, and then
it be
House
house.
is domain.
what is written.
Range is color.
Yeah.
In the
Okay.
So
Home of.
yeah, it's just a relation between that. That implies that there's someone.
Home.
Let's see.
Yeah,
Home
house.
of house.
Yeah. It's already it's suspicious because it is.
And the range is.
It's already selected.
That
Oh no, sorry, home of.
So we're in the object property. The domain is the house. What's the range then?
Home of man.
Okay.
drinks we already have.
All right. Left of.
Inverse of right of.
All right, well, make sure you save because my Protege just crashed on me.
Yeah, I just saved
Yeah,
a
that's
few
good.
minutes ago. I'll save it again here in a
I
second.
did not save at all, so no, it's all on you.
Um.
Yeah,
All right,
house and
so-
house.
So left of,
House left of house.
some other house.
Yeah.
so the range is, it's all
Also,
house.
yeah,
How domain and range is the same.
yeah.
Okay.
And the inverse is right of, no?
We need.
I don't think I don't know that that
I didn't build right of.
matters. Yeah. I don't think we need that because everything is left of because they're in a line.
Okay.
Yeah, I didn't. Yeah. Okay.
Mhm.
Lives in, so the domain is man.
Man,
Is the black
Range is house.
is black.
Is it, what is this the inverse of
homo.
Yeah. Is right next to me.
owned by?
Is right.
No, homo.
Or
Yeah. Is the
Homo.
right of me.
home of? Okay. Yeah, got it.
So what's
Am I? Yeah, lives in, yeah.
so if you have right of
Okay, inverse of
Yeah.
Owns.
owns.
Mm-hmm.
if you have next to
Domain.
certainty can be right of or left.
This was pets, right?
Okay, maybe human. This guy.
What are we
Yeah.
looking at? Owned by? Yeah.
Yeah.
It's a super
I was very
relation. A more generic relation, and this is what specific. So right now, it's good to list and then
All right. So owned by is the inverse of owns. The domain is pet. The range is man.
relation,
Owns, inverse of owned by.
right?
Guess we'll define the domain and the range for this one.
Is this
So
Man
this
and
would be,
pet.
yeah.
super relation? You see? First listing is you see this is like a production.
I
We
guess
do
we do
have,
have right of. Yeah.
yeah.
I mean, you could inverse it then. I don't think we have it written anywhere though, so I don't know it'll matter too
No, we
much.
don't. Left of
You know that we
domain is house.
tweak it, but it's like
And house, I
Range is
think.
house.
Yeah.
Yep.
in this way,
Okay.
right?
Smoked by
Sure.
is inverse of
Smokes. Last one.
smokes.
Okay.
Main
Okay. So you told me that
is
Cigarette.
cigarette. Range is man.
binary relation. So let's say he leaves.
Okay. Smoked by domain is
File I created.
Man.
man. Smoked by
I
ranges is a cigarette. Okay.
continue with the Protege implementation.
Yeah, we can run a quick check to see if we missed one.
You can't, you don't need. Because when you have one relation.
Yeah, this is the model. So this is anyway the starting model of and now we have to do some funky things with the instances. Yeah, maybe we can check all the object properties to see if we have everything. Because otherwise, if we miss one thing, then the reason is not
Individuals probably is what you would click through. Well, you can do it like that too, but and then just click through them.
There were
I did own.
Let's see where are the properties. Hang on.
Owns the range. I mean, the domain owns is
yeah,
human.
but you know what? Let's start with the list. Just
So like if you click the instances on the bottom left, you'll see the properties on the right.
Oh, okay.
Maybe.
Oh, but we don't have them specific for those, so it would only be in the classes, I guess.
Yeah.
I don't know. It's better like just straightforward list.
We don't have anything in there, so
Being
hang on.
1 second.
nitty-gritty detail
What do I
of
do?
one relation.
These tabs disappearing.
Not just
All right,
Yeah,
where's the
everyone's
individuals? There we go. Okay. So, all right, so we'll double check. So blue is the color and it associated with the house.
This is weird. Something is not right. It sort of says,
Okay, I'm back. Wait, it reasoned that blue was a type of house.
yeah. So something is not right. But you can click on it on a question mark, and then it says how it came.
No, the house.
Yeah.
Yeah.
Yeah, and then it says something like,
Other color equivalent to.
yeah, equivalent to.
I think
Yeah.
it's thinking color is house, I guess, which means we wrote that wrong.
Yeah.
I don't know nothing
It
about
is
how to
not
write that.
equivalent. It is.
So that's where so did I just not delete it?
Yeah.
Yeah, because it's exactly right. That's what I typed in there. It's under
Yeah,
equivalent.
Oh, instead
yeah,
of I see. So it got put in the wrong place, and then that's why house got put there as well.
yeah.
Yeah.
But it
Okay, so
goes for all things, for all these
delete that.
entries.
Yeah.
Delete that.
Well, I don't think I don't. That should delete itself. I think if you restart the reasoner, I
Yeah, but
think.
now we see another problem if you go to the subclasses on color.
So why is blue and green? Why is a color? Did I do
Well, no,
that
no.
wrong?
No, that's
The
right. But
problem
the
is it's
houses.
inferring, it's also inferring that colors are owned by men.
Yeah.
Oh, and subclasses I
So
see.
all
Oh,
these,
oh, no, no, that makes sense though, right? Because if a color is a house and a house is owned by exactly one man, it would
uh,
reason that the color is owned by one man. So removing the
yeah,
house should fix that in
yeah,
itself.
but it says
Not
now that color
necessarily.
is
We didn't define owned by as being like transitive or anything. Well, actually, that wouldn't even be transitive. That would be
uh,
right.
but color should not be equivalent to house.
I think because we wrote in equivalent to in color that it was equivalent to a house, that's why it reasoned that it's owned by
Yeah,
one man. I think. I don't know.
but
I
the
mean,
one you just deleted, we have more of those.
well, so
But
can't you restart the reasoner here and see if it goes away?
Oh, I see this.
Yeah, see,
yeah,
But I think we don't have any inferences having to do with color,
that is
probably.
true.
but maybe you can click on beverage, cigarette, and just
Yeah,
to
see
check
what
that
else?
everything is clean, because this was also not beverage
Yeah,
is not
see, so
equal,
we've done
also
it.
not good.
We've done it with everything.
Yeah.
Yeah, so that
Okay.
also needs to go.
All right.
The top is not. Oh, that's not. So,
Okay.
Yeah, this should have been.
Binary relations to translate. So leaves. What's the next one? Is there another?
Okay. So do we have to retype those in there someplace else?
Yeah, where do we put those?
So we covered them. So pools are smooth. This is
General class axioms? Or is that an
Sub,
expression versus an axiom?
okay, let's say I would say I already see that it's similar to
target for key addition with.
yeah. Okay. So what about I give it
Isn't this subclass of?
There is a difference between.
to be the same. We would say like house one.
I
I don't think we need to add anything disjoint. So would we do,
course is
but this is, I mean, it's an instance of a class that we already have it. I don't think we need to subclass anything.
is used here. So pools are
I'm
smooth.
sorry, that's silly of me. We do need to make everything disjoint.
Of course.
Yeah,
That's where our problem's coming from. None of the instances can have more than one class here, right? It is not the case that a cigarette can also be a color, and we need to say that in our
yeah,
disjoint. So we only need to assert the disjoint with stuff on one class, and then I think all the others should get it. I'm not entirely sure of
So
that.
in other words, had we left everything we just deleted and put in the disjoint with, it would have been right, is what you're saying?
Yes, sorry.
Okay.
I'm also working on my computer, and I missed it.
That is totally okay. You're the only one with the answer, so you don't have to be sorry.
Uh,
I just
I'm
control Z'd everything. So I put it all back in.
You
Also,
did.
in this course, you would have so many synonyms.
Worked nice. Okay, so now I need to add disjoint in here, right? So beverage is disjoint with everything else.
Again,
yeah.
it's a monadic predicate. We already decided it was
Will that do it?
binary. So it's done. So whenever
I mean, yeah, but yes, a beverage is not any of those other things. Oh,
this is
No,
And
it's
see,
yeah, so now it's inconsistent.
see,
Either,
click explain. No, click. It'll tell you what.
fantastic.
Well, that you have to rerun the reasoner now. I think.
Leaves.
yeah, it cannot be
Next,
like and disjoint and equivalent. I mean, that's just not how it works.
we have leaves.
Well, that's
Yeah,
found a whole lot of explanations.
yeah, you can do stop, stop.
That doesn't seem good.
No, you can do stop, 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 stop.
lives and next to.
Do we have it next time? We already
Yeah,
have
so the
Yeah, you can't
disjoint
make
just
it all
caused the
disjoint. Yeah.
thing with everything. Yeah.
Okay.
leaves.
I think what you have to do is make separate disjointness axioms for each of the other classes instead of having it all in one.
You see that
No.
leaves next to this one word.
Okay, so now we're back to where we were.
Right,
So
and so now we have to add
Yeah,
separate disjoints. I don't know how you
No, I
determine.
think you can do an all disjoint somewhere on the active ontology. I remember there is something like general class axioms or something like that. And then you can do all disjoint.
But it's not it depends really what you're modeling. This is a big decision.
Yeah.
But we already had this because it appeared. So this decision
I don't
is
really know how to do the disjoint, to be honest.
all these decisions. I talk about what do you know?
No, I think
Universe.
just pick one of the other classes to make disjoint and do it one at a time for each of them. Luckily, our ontology is small enough that this will work.
So cigarette is disjoint with
Anything.
Yeah, anything that's not cigarette, because all disjointness means is that those two classes cannot share the same instance.
so okay, so it's disjoint with a pet. Then I'll add
Carter today.
You see
man. I'll add house. I'll add color. So can't add the can't be disjoint with itself, I don't think.
No,
Yeah,
that would
we
just
would
be
not want it to do that either, even if it could.
Okay, so it,
Yeah, I don't know if you need to do them for each thing, like backwards, but I guess try it out now and see what happens. If not, then you can do it for each one. I'll just run the reasoner first before you waste the time, right? See if it works.
Being too expressive, like overkill is not a big deal.
You know my
It will
line
take
on
us
the
more
two
time
main
to
ontology
to model to the overkill, but it's better to do more than to use
Okay.
it, right?
So
it
wait,
didn't do anything. Like
it's still reasoning. Go to click the one that you did all of them in. I don't know which one. Cigarette, I think. Yeah, no, I think it works. So I think you just have to do specific for each one, all of the different classes, and I think it'll work.
okay. All right, disjoint. So this is beverage, so everything but beverage. Cigarette, color, house, painful.
When you a lot, it's better to parse.
Now look, just real quick, synchronize the reasoner on this, and I think the other ones will go away, and it'll only be coffee, milk, orange juice, or we'll fuck it all. Unfortunate. All right, click it.
Eh,
See what happens.
here
Yeah,
we
it's
go.
just gonna
Oh, a
raise.
million. Wait, so why though? Beverage disjoint with man, orange juice type beverage, drunk by domain man.
Oh, we're probably still going to, well, it's probably, don't worry about the reasoner until you get the disjointness axioms on all of the
Okay.
classes.
Okay.
Because I
All
think as
right.
long as there are classes now that do not have disjoint axioms, when it's building a model, the reasoner will assume that like, hey, there's at least one instance where anything that can be jointed will be.
So did anybody solve it?
It's not quite, not there yet.
No.
Yeah.
Also,
Yeah,
because
all right,
we're
all
not
right.
following your slides.
That's fair. You should have.
Actually,
Well, it doesn't be immediate, but we're
Yeah.
I have a
You're
question.
learning. That's the important part. Yeah. Yeah. Awesome.
Yeah, something I'd like to learn. Is it possible for me to make a class equivalent to a list of individuals in Protege?
Absolutely. You can enumerate the class and you can do it in a couple of ways. You could just hit that equivalent to button and you can type
Yeah.
the individuals with ors between them. Or if you're a pedant, like I sometimes am, you can put brackets around the individuals because the or is interpreted over sets and they're singletons. But
Okay.
simpler way.
Yeah.
Yeah, that's right. And also that has the benefit of defining closure over the class. So you don't have to do any hijinks, logical hijinks to close the class off. If you want to say all the cigarettes are just these packets and these 5 alone, you would enumerate the class.
Okay.
Great question.
I do have a problem with this though. It's supposed to be in the class expression editor that you do that.
You can do that right here in equivalent to, right? If you click on equivalent to right there, you
Yeah,
can
no.
you can just type it into the class expression. Yeah. Just type in the names.
Yeah, when I do that, it's like highlighting the first name as being a mistake.
Oh, you have to connect it to something. So type in the name, then hit or, and then type in the name. You have to connect them. Yeah, you can't just say it's equivalent. I mean, it's not going to let you say it's class equivalent to some instance. I mean, it should technically allow you to say it's class equivalent to some singleton, but
Yeah.
yeah, try it out. Anyway, gotta go. Barry's about to teach class. It's over here.
Mhm.
Good luck on your future endeavors. Project 3, get it done. Figure out mappings. Hit me up on Slack if you need.
Yeah. Sam, can you post it on Slack, your results?
Yeah, I'll post this in the Slack channel.
Great,
I'll
thanks.
post this